Good morning, good afternoon, good evening, depending on where you are and what time of day you're watching this presentation. I'd like to start by asking you a healthcare related question. Have you ever wondered what's in your medical record, whether it being a record at your doctor office or at a hospital that you visited or a laboratory or an MRI center or radiology center or insurance company or even at the life insurance underwriter. A lot of times you may be declined for certain limit on the life insurance. You don't know why. They may tell you something, we've seen it in your record, but you don't really know what they have seen. So most of us, like me, the answer is yes. And I've not seen it and I don't know what's in it. I might have requested something for a special case and got maybe a page of certain procedure, but in totality, I've not seen my record and I don't believe many of us have seen it. Wouldn't it be important? Wouldn't you want to be at the center of your own health and provide this information to whoever you want and whenever you want? The patient has a right to see their records and to see the data that's gathered across a geographical distance at their fingertip. The patient has the right to make its own health decisions and choice of medical team. The world population is dire needs of better health information, and be able to make a better decision on their health. The technology is here, and there is a lot of enthusiasm and a lot of research and development is going on in academic and public sectors related to health. At the core of all these studies is something called electronic health record. And corresponding to electronic health record is electronic health record ecosystem. And we talk about both of these and what's the differences between the two. I'm Hamid Ghazawat. I'm your fellow colleague in CSCI 582 class with Professor Reza. I'm a PhD student at the School of Electrical Engineering and Computer Science, the University of North Dakota. I'm a senior program manager at Mars Northwestern Mutual Company and adjunct lecturer at Northwestern University in Evanston, Illinois. And that is the topic that I'll be discussing about next generation of EHR in the focus. It's the focus of my presentation today. What I'd like to discuss is what will be your takeaway from the presentation today. I made a similar presentation, but from a different aspect and from different perspective back in March of this year, 2025, and that was called Patient-Centric Electronic Health Record. It was more of a survey. Now, this is a research presentation, and at the end, I will provide a contribution to this field. So the takeaway that I'm giving you today is first, we're going to talk about a better understanding of EHR and why is it important. We talk about attributes that this ecosystem needs, a collection of medical, Internet of Medical Things. It's called IoMT as opposed to IoT. This is IoMT. And systems that together provide this comprehensive EHR data and decision-making. I will give you a use case, which is a network of heterogeneous devices and systems, old and new technology. And at the heart of it is emphasis on privacy and interoperability aspect, because we're talking about heterogeneous devices. So interoperability is the key. And also, since we're talking about health record, then privacy is even more important. So these two aspects are critical in this presentation. Then I will address implementation aspect of this electronic health record and why blockchain has become so important in the healthcare. and what are the attributes that blockchain supports, and what are the shortcomings. At the heart of my presentation is me providing a novel taxonomy that is intended to address the key privacy and interoperability challenges of this ecosystem. What is EHR? EHR, in a simple way, is collection of patient demographic data and health-related information. It's a structure or unstructured, it's a charts, it's a handwriting, it's a lab results, it's a radiology pictures and CDs and discs and all those. On the other hand, there is also something called EMR, electronic medical record, which is related to one center. So if you go to doctor and doctor has your medical records, that's EMR. But when the doctor record, the lab record, the radiology, they all combine in one place, in one central location, that's EHR, and that's what the focus of my work is. Why EHR system? It's a collection of all the records, as we discussed. It facilitates easy access to quality care, wherever it's going to be. So distance is not going to be an issue. You will be at the center of your own health. Through this EHR, it gives you that ability to make a decision based on fact and data that you have. You can choose your own medical team of doctor, nurses, surgeon, radiologist, cardiologist, whoever you have, and you can have a meeting, and this team can be scattered across the globe, and you can have a real-time meeting with real-time data from your test results and be able to, in a secure way, have a good conversation. And then at the same time, you get accurate diagnosis of your condition based on your symptoms and measures, and also based on thousands and millions of data points across the globe that can be used in an anonymous way. And then, of course, short-term and long-term prediction and trend analysis is at your fingertip once you have this data available. And that's why EHR system is so important. I'm going to give you a use case so you get an understanding of how things work, and then we get a little bit more in detail. So the simple use case is that you are a patient, and then you have some medical devices that you use to collect data. Okay, the medical devices can be a blood pressure machine, diabetic machine, heart rhythm collection, a CPAP machine, a pacemaker. And so a lot of devices are available, thousands of devices are available. You may be using few of them. You may have some with the older technology, which is typically manual data, or at times you take the device back to doctor and they take the data out to study, or it could be a new IoMT devices that are smart, which has a tracker and sensors, and it does Wi-Fi transmission of data. On the other hand, you may have a doctor office, an old doctor office, it's just a single doctor office. They don't really have high-tech setup. They do still use the paper pencil record, and they have fax machine and those. And you may as well have a doctor office, which is high-tech with all the gizmos available, and it's a lot of interoperability and connectivity to cloud and other things. Similarly, labs that maybe an old technology with labs with new technology, that they have their own disks as well, and a disk system and storage. These are all, so as your IoMT devices collect data, it communicates to your doctor office, or you take it to office to take the data out. And similarly, from doctor office, they send a request for test for an MRI, and that data is sent back to the doctor, put into their storage devices, or they all send their data to cloud system. And you can see that it gets a little bit complex with the new and old. It's a heterogeneous devices. How do they communicate? How do they send the data to a cloud system? How do they send to each other? So that we will get to it later. But at the heart of it is that this is a typical use case. You all see this, you all have this. And then the cloud system has a data storage. You may also have a blockchain for security and safety of the data, whereas cloud system may support you on maybe scaling the data on huge data and fast, but it may not be as secure and the data can be compromised. So you may have a combination of cloud and blockchain. So blockchain give you that safety and security that you need. And cloud can be the scaling. So you may just go to cloud for speedy, and then from cloud, you send it to blockchain. And then blockchain itself may have some issue, which it does. I will talk about it later, that it requires some Ethereum connection for some smart contract negotiation for privacy and safety and those things. So at this time, just look at it from patient perspective, different layers. There's a device layer, service system layer, and and then the database management layer. So, excuse me. So in this ecosystem that we're talking about, what are the quality attributes of such a system? Certainly security, privacy, interoperability based on some kind of standard, which in this case, in the healthcare, it's health level 7, fast healthcare interoperability resources. That's really a standard that has been used across all the devices of the modern devices. Scalability, maintainability, usability, these are all key attributes that this system must have. And all of these will help in improving decision-making through better data integration. That's why this EHR health ecosystem becomes so important in healthcare. The key aspect of such a system is interoperability of these heterogeneous old and new devices. Privacy, as we talked, health-related has to be very secure, privacy. And then interconnected, flexible, quantum-based, unbiased. Because most of the data, when you start comparing, when you take trend analysis, you try comparing, it depends what sample data are there from what sector of the population there are. So the data that's available may be biased. So somehow you need to take that bias out by some kind of algorithm and then use the quantum base to make it fast and speedy decision. You may have a standardized product. You need to have a standardized protocol that all these devices communicate to each other. And many other attributes that we will talk about them a little bit later on. But at the heart of it is a sound architecture and well-defined taxonomy. That's how these heterogeneous devices work together. And then once you put the technology aside, the other important part is the socio-economic factors, the trust factor that the patient and the team, doctors and those, they trust the result. The operational aspect, data governance, regulatory, which is really important. Regulatory can make and break your system. And then the question comes, is blockchain suitable for this IoMT EHR ecosystem? If you recall, I surveyed a lot of papers, and I have a result of that survey that I'll talk a little bit. But let's take a look at that survey presentation. So I have just a slide or two that just summarizes about the blockchain in this situation. What is a blockchain? It's a secure way of, it's a chain of blocks. It's a link, it's like a linked list that you used in undergrad in a database management system. So it's a block of information that they link together. It's a way of sharing data and storing data. Each block is linked to another block through a cryptographic number, which is hash number. It's very safe, secure. Nobody can break into it, and nobody knows that number. It's decentralized. It's a consensus mechanism. That's how all the blocks need to make a decision as to whether you are the right person to make a change, edit, or delete, or do something with the content. There are several ways that you do this consensus mechanism. There's one called proof of work, POW. That's a very complex and very long way of each one has to check with every other one's to see if that person, each block has to check with every other one to see if that's the right block or not. And if you have maybe tens and hundreds of these blocks of information, it's going to take, months for making that decision. So on the contrast to that, there's something called proof of stakes, and that's by voting. So you participate, you bet, and you bet some of your coin that you're the right person. And if you're faking, if you're not the right one, you lose that coin. And it's very quickly, it's obvious that you will not be the right person. So the safety and security is there as well for the proof of stakes. But the key inherent quality attributes in the blockchain is something called CIA, confidentiality, integrity, and availability, among many other ones. So let's see what those are. So Huang Gao, with her colleagues, they did survey of blockchain, and they concluded that blockchain provides users with desirable features of decentralization, autonomy, integrity, immutability, verification, fault tolerance, anonymity, auditability, transparency, and a lot of others. With these advanced features, blockchain technology has attracted great academic and industrial attention in recent few years. And blockchain confidentiality, and I look at it, and it focuses protecting data from unauthorized access. So it's highly confidential data, and it encrypts the data. So the conclusion of the papers that I read about confidentiality is through also some Google AI overview. Also, they said that blockchain inherently supports confidentiality. Integrity, again, Stella, Tony, and her colleagues, they did a study of blockchain, especially on the integrity, and they concluded that blockchain technology provides this much needed data integrity assurance with its high-level security capability. The blockchain solution has cryptography encryption that protects data from attacker, prevents potential fraud and manipulation, reduces the chance of stolen or compromised data. So you can see the integrity is a key aspect of blockchain. And then, of course, availability, that Zhang Teng Ko and his colleagues, they concluded that the blockchain system is distributed, immutable, and remains highly available, and thus is suitable for recording clinical research activities. These are a lot of other quality attributes that blockchain supports. I've put it in this table. You can see the quality attributes, a description of what each quality attribute there is, and blockchain context, how blockchain support these qualities. And I put some references to it as well down here. Now, looking at privacy aspect, the key takeaway from all these quality attribute studies shows in this simple sentence that Yaga and his friends, they concluded. Blockchain's strength lies in integrity and availability. Privacy must be engineered separately via encryption or off-chain protocols. So privacy, which is key for EHR, as we discussed earlier, is not inherently supported with blockchain. So that's very important. Just keep that in mind. In another word, blockchain supports confidentiality, but it's not inherently private. To fully support privacy, then blockchain needs to also integrate with other tools such as encryption. I mean, that's typical, right? Encrypting the data through AES 256. Zero knowledge proof. That's another way that blockchain does privacy, and that's by proving without showing the data. So the data is not visible, but you can prove if this person is the right person to have that data or not. Confidential tractions, private permission chain, and like Hyperledger Fabric, and all those. So adding this to blockchain and also having a hybrid blockchain with hybrid of architectural style and patterns, a good database management strategy, a good data governance, and a solid taxonomy will provide a powerful and viable solution. Because this blockchain is not just for keeping record, it's really for the whole ecosystem. So the entire ecosystem needs to be compliant to give you this powerful solution. The challenges that it has, it's several-fold. One is interoperability, because we have heterogeneous old and new devices. So interoperability is the key. And also maintaining data privacy during transmission, storing, and accessing and using. So as you remember, our use case, you had user, devices, system. The data has to flow through all these layers, right? So the privacy of data has to still be there as you're transmitting, storing, accessing those. So that's really a challenge of this ecosystem that we're talking about. And the data, there is a fragmented data records that needs to be organized. So IoMT devices and EHR systems often vary in capability, communication protocols, and security features, making interoperability and privacy protection challenging. So that's really a key takeaway from this slide. How to address this challenge? To address this data challenge, a multi-layer approach is needed, because you can't just have a privacy at, let's say, user level, then not worry about at the device level, at the system level, at all those other ones. So first, you have to be able to encrypt and access control to have this data secure, okay? And you have to comply with the privacy regulation. So that's the key to address the challenge. And the second is to come up with a taxonomy for heterogeneous IoMT devices and system. Okay, so that's another one. So this taxonomy shall categorize defined components that achieve seamless integration and privacy across diverse medical devices and systems that they should adhere to. So that's one way. So at the heart of it is the taxonomy. This taxonomy provides a structured way to design and evaluate these devices and systems, ensure interoperability and privacy, and provide a framework that if the devices and system adhere to, then you are guaranteed that if implementing such a system, it would be interoperable, secure, efficient, and compliant with privacy and relevant regulations. So the population, the doctor offices and hospital, all those, they want this guarantee. So if you can come up with a taxonomy that adhering to it will provide all these challenges, and it will address, and will provide you with the quality attributes that are needed, then complying and adhering to it would be a simple thing. The key in addressing in establishing a patient-centric IoMT EHR ecosystem and transmitting patient information among heterogeneous old and new devices and systems is, and this is important, to establish a taxonomy that categorizes and defines components relevant to privacy and interoperability. And here is my contribution. My contribution is to define and develop such a taxonomy. And what I would call it, unified privacy and interoperability taxonomy for heterogeneous IoMT EHR ecosystem. This taxonomy is a layered architecture. Since our use case is layered, means our ecosystem is layered. So the taxonomy has to address the device layer, the network layer, the data management layer, addresses privacy consideration, application layer, governance, and compliance layer. So it has to address all those layers. So the taxonomy is a layered architecture taxonomy. At the heart of this is unified privacy and interoperability is necessitate that you have security integrated at each layer, adopt a privacy mechanism for obtaining and managing consent for data sharing at each layer, standardizing and adopting universal data format and communication protocol for interoperability. Again, you can see that security, privacy, interoperability at each layer becomes very important. And overlaying this taxonomy on our use case, you will see how and what criteria for each are needed in this case. The smart contract, the ABAC and API gateway. You may need some kind of adapter API created to communicate with older devices and so forth. And you can see interoperability at all this layer has to be maintained, and privacy needs to be maintained. I have, in the next few slides, I deep dive into each layer. What category is it? Like at the device layer, you're talking about wearable devices, watches, trackers, and pacemaker, insulin pumps, all the categories. These are categories of devices. And then what are the considerations, which are data standards that you have to use, security measures. At the network layer, you're talking about communication protocol, what protocol to be used, standard. These are all the standards that some devices use. Can you use one or combination of these? Interoperability standards, the security measures. At the data layer, what kind of storage, secure cloud storage, edge computing. That's another thing. All these devices, they may have their own little memory card that store data, and that's highly risky as well. So how you address that risk, that the taxonomy needs to address that. Privacy preservation, compliance with the GDPR, which is a European standard, and HIPAA, which is American standard. Those all need to be addressed. Application layer, remote monitoring, telemedicine, the dashboard, mobile connection. Those are things that at the application layer you're concerned. Like a regulatory compliance, regulatory standards, auditing, be able to monitor, policy management. Now, such a taxonomy, implementing such a taxonomy has challenges. So what are the challenges? First is to be able to implement this across all these heterogeneous devices. That's a challenge. And validating the taxonomy. Adhering and compliance to the standard by the older. So how do we want the older systems be able to communicate to this taxonomy? So some kind of developing some kind of adapters that each device will use. Security risk in edge computing, I alluded to that. Scalability, wide scale adoption across the population. That's important. And how do we scale this so that the population accept the result? That's the challenge. Performance consideration, validation of other quality attributes, such as availability, maintainability, preservability. How are we going to prove that? So those are challenges that I see in front of us for such a system. So future direction is address each of the implementation challenges. So each of these will take some time, some study to come up with. So the taxonomy is there that will guarantee a good ecosystem. But these challenges, each of those challenges need to be addressed separately. Implementing a use case to validate the taxonomy for each category and each of the defined architectural layer. Integrating data mesh, that's another thing which is important. Integrating data mesh domain model for patient-centric. So if we're talking about patient-centric, it needs to be a focus as a domain model. So data mesh give you that capability. And at the end, adding AI enablement for precision medicine to be able to trend future short-term and long-term feature. So that's the future direction. With that, I thank you so much for watching and listening to my presentation. I really appreciate the time that we had together today, and I would appreciate any and all kind of feedback, good, bad, otherwise ugly. So if you would like more information, feel free to drop me a note, email me, and I wish you best.